Welcome students, Mr. Munir here. Time for some math. Today we're doing lesson 13.3, volume of spheres. Now, what's the essential question? How do you find the volume of a sphere? That's the big daddy question right there. How do you find the volume of a sphere? Now again, same thing with cones. I'd love to derive for you how to get the formula. I'd love to derive the formula for the volume of a sphere for you. But in order to do that, we need calculus, and that's not quite a tool that we have in our toolbox just yet. So we're going to have to just settle with knowing the formula, me just giving it to you and you trusting me. Now, interestingly, this first page here goes through just something kind of cool. If you have a radius and a height, which we say the height is double the radius for a cylinder, well, for a cone, again, the radius will be r and the height will be double the radius r. So, for instance, if the radius is 3, then the height would be 6. The radius is 3, the height would be 6. Well, we know that the volume of a cone is 1/3 the volume of a cylinder. Well, interestingly enough, we know that a sphere is not 1/3 the volume of this cylinder. It's actually 2/3 the volume of the cylinder. And that's for a specific sphere with a specific cylinder. Remember, we said the height is 2 times the radius. Well, why does this work? Well, a sphere is a ball, right? Sphere, okay? We know that a sphere has the same radius all the way around. So if I take this point, that's the center of the sphere, and go all the way to the top, that's r, and all the way to the bottom, that's another r. So from the bottom to the top of the sphere is 1, 2, r. So in order for that sphere to touch the bottom of the cylinder and the top of the cylinder and the sides of the cylinder, the height of the cylinder needs to be 2r, 2 times the radius. Cool. So for a specific sphere-cylinder combination, where the height of the cylinder is 2 times the radius of the cylinder, then the sphere, the volume of the sphere, is 2/3 the volume of that cylinder. Well, cool. Well, if the volume is 2/3 the volume of the cylinder, then all I have to do is plug in, instead of h, I plug in 2r, because h is equal to 2 times the radius. So I plug in 2r here, and then I go ahead and do this out. So what is this going to look like? Let's take a look here. This formula, if volume equals 2/3 pi r squared, well, this is the same thing. I can get rid of that parentheses is 2/3, and I use the associative or commutative property to reorder this. 2 times pi times r squared times that r will keep here. So the 2 I brought here, the r I kept there. Well, 2 times 2 is 4. 2 is the same thing as 2 over 1, so top times top is 2, over bottom times bottom is 3. So 2 times 2 is 4, sorry, and 3 times 1 is 3. And I get pi, and then r squared times r to the first power. Remember, if I have r squared times r to the first power, I'm multiplying these powers, I add the exponents. So this is r to the 2 plus 1, or r cubed. So that becomes r cubed. And I've now derived the volume of a sphere. Now, this was kind of a roundabout way to get the volume of a sphere. You have to have a specific cylinder in order to understand this. You also have to know in advance that a sphere with those dimensions in a cylinder of those dimensions is 2/3 the volume of a cylinder. So this is not really a rigorous proof of the volume of a sphere, but we can see in this interesting way what the volume of a sphere is, and we get this formula here. So the volume of a sphere, the important ding 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 thing is the volume of a sphere is 4/3 pi r cubed. Cool. So notice that we don't have an h term here because it doesn't make sense to talk about the height of a sphere. It just makes sense to talk about the radius of the sphere because it's the same radius all the way around. So you only need one dimension. Whereas for a cylinder and a cone, you need to have the radius of the base and the height. In this case, you just need the radius and you're fine. Okay, so that's it. That's it. We answered the essential question. How do you find the volume of a sphere? Well, the volume of a sphere is equal to 4/3 pi times the radius cubed. Cool. All right, well, let's take a look at an example problem. Let's go to next here. There you go. Gives it to you nice and simple. Volume is 4/3 pi r cubed. All right, well, they want us to use 2.1 centimeters. I'm not going to start us off with a decimal, but oh man, 7? That's not that much better. 7? I don't want to cube 7. Oh man, wait a second. That's the diameter. If the diameter is 7, then the radius is 3.5. Oh, I don't want to do that one. You know what? I'm going to make up my own problem. I'll use their sphere, though. Okay, so let's take 7 centimeters away. So goodbye. So this is now a new problem. And I'm going to make this, instead of 7 centimeters, I'm going to make this, let's make it something easy. Let's make the diameter, 6 centimeters. Should we? Yeah, I think so. That's a good one. Okay, so the diameter is 6 centimeters. So I don't quite have the radius yet. I have the diameter is 6 centimeters. So the radius is 6 centimeters over 2, which is equal to 3 centimeters. Cool. All right, now I can find the volume of the sphere because all I need is the radius. Is 4/3 pi r cubed, and r is 3 cubed. So it's 4/3 pi. What's 3 cubed? Well, that's the same thing as 3 times 3 times 3, right? So 4/3 pi 3 times 3 is 9 times 3 is 27. So times 27. So I'm going to reorder this using my good old commutative property of multiplication. 4/3 times 27 times pi. And now I could do 4 times 27 over 3 times 1, but I know that 27 is a multiple of 3, so I'm going to cancel that 3 and make this 9 to make my life easier. 4 times 9 is 36 pi centimeters cubed is my volume. Now, of course, I can always use 3.14, or I can just use pi to approximate this answer, and I get 113.1. So the volume equals 113, let me not write it right there. Volume equals 113.1 centimeters cubed, or cubic centimeters. That's it. That's how you find the volume of a sphere. Again, here we were given the diameter. If they gave us the radius, that's just one less step because we don't have to find the radius using our formula where the radius is d over 2. So if they give us the radius, it's easier. If they give us the diameter, we can still do it. But the point is all you have to do is just use this formula. Okay, simple as that. 4/3 volume of sphere is 4/3 pi r cubed. So let's see what else they have for us. Well, soccer balls come in different sizes. One soccer ball has a diameter of 22 centimeters. What's the volume of the soccer ball? Okay, first step, find the radius is 11. Second step, plug it into the formula. Boom, you're done. At this point, you've now gone through 3 lessons where what you are doing is you're simply getting the dimensions, plugging them into a formula, and solving. Okay, so a lot of this is just arithmetic, doing multiplication. You can do that stuff. That's almost that's what you've been doing for a long time. The thing that you've gained in this module is 3 specific things. You know the volume of a cylinder, you know the volume of a cone, and the volume of a sphere. These are the kind of things that you should commit to memory. You could derive the volume of a cylinder pretty easily if you need to, using the volume of a prism. But the reality is that it's just easier to memorize them. Volume of a cylinder, let's go through them really quick, okay? Volume of a cylinder is equal to pi r squared times h. Volume of a cone is equal to 1/3 pi r squared times h. And the volume of a sphere is equal to 4/3 pi r cubed. All right? So commit these to memory. Just memorize them. It's the easiest way to do it, okay? If you want more insight into any of these, there's lots of videos you can go online and watch. If you want to find out how to derive the volume of a cone or the volume of a sphere using calculus, just Google search or on YouTube, how do I derive the volume of a sphere? And you will find the way to do it. It's way beyond this level of this class, but you know what? You're learning at your own pace. So guess what that means? If you want it, go for it. Man, this is so exciting. I just love doing this. I love doing this for you guys. I love, love, love knowing that you are watching this video and you're learning. God bless your beautiful brains. That's all for me for today. Until next time, may God bless you and enjoy your math.